So today's topic is Javathread. So we have a lot to cover, and these are the main topics that we are going to cover in this presentation and hands-on lab. So we are going to spend our time looking into how we can create Java threads, and then we are going to spend on synchronization and inter-thread communication. So I would say these and these are probably the most important topics in this presentation. So a little bit of basics for those of you who are not familiar with the concept of thread and process. So what is a thread? You can think of a thread as a single sequential flow of control within an application to perform a task, programming task. So typically threads are used to handle concurrent operations. So concept of single threading versus multi-threading. So single threading application has a single thread to perform its task. Most of the modern applications are being executed in multi-threaded mode, meaning it will have a multi-threads and each of thread will perform a single sequential flow of task. So multi-threading in Java platform, so every application, every Java application has at least one thread, and if you are running Java standalone application, is the main thread is called the main, and then it will actually create other threads. So if you count in fact system threads, every application is in fact multi-threaded application, but from a developer programmer's point of view, you are going to start one thread. Then if you need another thread, then you're going to create another thread. And we're going to see how we can do these things in Java program later on. Okay, thread states. So again, these are somewhat obvious concept. Running state, ready to run state. So running state is the one that actually currently running, and it is the one that owns the CPU. Ready to run is a thread state, can run but is not running at the moment. And resumed is ready to run after being suspended or blocked. Suspended is that voluntarily allowed other threads to run, and blocked is waiting for some resource or event to occur. So these are possible states. Okay, thread priorities. So it's basically priority assigned to each thread. So higher priority thread should receive CPU control before lower priority thread. In Java, the thread has a value from 1 to 10, and 10 is the highest priority, meaning it has the highest priority of being run. So if there are two threads, one is 5 and the other one is 10, obviously the thread that has priority of 10 will actually get the CPU before the priority 5 thread. Okay, so context switch. So context switch occurs when a thread snatches the control of the CPU from another. So context switch occurs when running thread voluntarily relinquish the CPU control so that other thread actually get the control. And running thread could be preempted by higher priority thread. Okay, so when there are multiple same priority threads are present, then which one actually gets the CPU control depends on the operating system. On Windows, it's time slide, round robin, and Solaris is executing thread should voluntarily relinquish CPU control. Okay, so these are all basics of threading. Alright, so demo, we are going to run view all thread programs in the hands-on lab. So let's see this run application. So we have two thread group. One is system and the other one is a main. So this GUI application, swing application, is actually from this main thread group. And main thread group has main, and this main is creating other threads, and so you can see these threads have priority. Okay. All right. Okay, so moving forward, thread class. So thread class, you can create a thread object by passing the name or without the name, and you can pass the runnable object to create a thread. We are going to actually learn how we can use these things later on, so it's just the reference information. So these are the constant values for specifying priority, max priority, mini priority, and known priority. Nothing that much exciting here. We can get the current thread, and we can get the name of the thread. We can set the name. We can get the priority, and we can see whether the thread is alive or not, meaning the thread is running or not. Okay, moving forward. Okay, so we are going to spend some time learning how we can create a thread. Okay, there are two ways of creating Javathread. So one scheme is extending thread class, and the other scheme is implementing runnable interface. You probably have seen both examples. Okay, now each of the scheme has two ways of actually doing things. Okay, so let's take a look at the first scheme, extending thread class. So basically, you are going to create a subclass extending thread class, and then you are going to override run method of thread class. And then you're going to create an object instance of that subclass. So obviously that is an object of thread class. And then you're going to call start method of the object instance. And what happens is that then Java runtime will start the execution of the thread by calling run method of this object instance. Okay, so let's see the code. Oh, by the way, so as I said before, there are two schemes in this particular method, meaning, so as I said before, we have two different ways, right? In the first way, we have two different schemes, okay? So for extending thread class, we have two different schemes for starting a thread from a subclass. Scheme number one is the thread and start method is not in the constructor of the subclass, and this is typically the example code that you probably have seen. In this case, you have to manually call start method. So start method needs to be explicitly invoked after object instance of your thread subclass is created in order to start the method. Scheme number two in this case is that start method is in the constructor of the subclass. In that case, you don't have to call yourself the start method because it is called inside the constructor. So let's take a look at an example of this, both schemes. Okay. All right, so this is scheme number one. Again, this is more popular scheme. You probably have seen this example more than the other one. So in this case, start method is not in the constructor of the subclass. So here you are extending thread class. Okay, so print name thread extends the thread class. Okay, so I saw a message from Paul and lost audio. You guys having a problem actually listening to me? Can you send me a signal that you can listen to me okay? Oh, good. Okay. So, all right, good. All right. So this is extending thread class. Okay. Now here there is no the start method here in the constructor. Okay. All right. So what you do is you are going to create an object of your subclass. Okay. So here I created an object of print name thread object, and then I'm going to call the start method manually. And when I call start method of this subclass, then Java runtime will execute the logic defined in run method. Okay? All right. Same thing here. I'm creating second thread, and then I'm calling start method of the subclass again. The second thread is going to run this. So now when I run this application, I have, I'm sorry, when I run this application, okay. Okay, I'm actually still looking at the scheme one. Okay, yeah, so I was looking for this one. So when I run this main method, basically I have a 2 thread running. Okay. All right, so let's move on to scheme number 2. So in this case, start method is in the constructor of the subclass. So here, in scheme number 1, we didn't have this start method, right? So in scheme number 2, we are going to start this thread as part of the constructor. Okay, so it runs the thread once instantiated. So in this case, basically, I created a thread object, and that's all you have to do, because the constructor of this subclass of the thread will actually start the thread. Okay, this is actually less frequently used than scheme number 1. Okay. So mostly you probably have seen the code that actually manually start the manually calling start method of your thread object. Okay, so that's actually the method 1 of the creating a thread by extending thread class. Okay, so all right, so let's take a look at the sample application. So this sample application is something that I showed in the slide. So here we have extend thread class 0. So I'm going to just run this guy. So basically it's just displaying alpha numeric character A 10 times. So if you take a look at the code, basically, yeah, so this is the code. So this print name thread extends the thread, and here we don't have a start method. And this is running method, so we are basically displaying the A 10 times, and this is a main method, and the main method here we call start method. Okay, this test 1 here we are basically doing the same thing. Okay, so here this is we actually created 3 thread. Okay. So when I run this application, and it will actually display A, B, 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 B. I mean, so this is from thread 1, this is from thread 2 or 3, and this is from the 3rd thread. And this one, test 2 is now, this is the case that the result should be the same, but here we are, we have a start method invocation inside the constructor. Okay, so moving forward. Yeah, you guys, John said that the audio still is muted. That's interesting. Can you hear me okay now? One, can you actually hear me okay? You said that audio appears muted. Can people hear me okay? Okay, good. So David said you can hear me okay, so I'm going to move on. Okay, so now we are going into second way of creating thread. So here we are going to take a look how we can do the same thing by implementing what is called runnable interface. Okay, so this is again quite popular scheme, so you probably have seen examples of this one as well. So in this case, you are going to implement runnable interface. You can think of runnable interface is a unit of task. Okay, so when you implement runnable interface, you are defining a unit of task that will be performed by a thread. Okay, and you still have to implement the run method of this runnable interface. Okay. So in this case, run method is like a name method of the new thread, because this is a task in a unit of task, and that run method is actually being invoked. Okay, so why use runnable interface? One good example of why you have to use runnable interface scheme as opposed to extending thread subclass is that if you already have the parent class, then you cannot extend thread class, right? Because Java does not allow you to have a multiple parent. Okay, so class that implements runnable can run without subclassing thread by instantiating a thread instance and passing it itself as a target. And we'll actually do another comparison later on. Okay, so now as we have seen in the first way of actually creating the thread, extending thread, there are also two ways of starting a thread for a class that implements runnable. Okay, same deal. Whether you have start method of so call a thread, create a thread object, and starts it explicitly an object instance of the class that implements runnable interface. So in this case, start method of the thread object needs to be explicitly invoked after object instance is created. Here, second scheme is thread object is created, and within the constructor method of the class that implements a runnable interface. So in this case, the caller thread just needs to create an object instance of runnable class. Okay, so let's take a look at an example. So this is the scheme number one of the second method. So here we implemented a runnable class. Okay, so again, this is an example where I already extends some class, so you cannot extend thread class. Okay, so you got to use this scheme. Here I implement runnable, so we have to provide the unit of task in the form of run method. Okay, so we are doing pretty much the same thing here. Okay, again, we don't actually call start method here. Okay, now, so we are going to have runnable object. Okay, so we have a runnable object, and then you are going to create a thread object by passing that runnable object. Okay, so you're passing runnable object as an argument. So in this case, you're creating a thread and you're giving a task. You're giving a unit of task that will be performed by this thread, and then you're going to call start method. Okay, and then it will actually perform the run method of this runnable class. Okay, so this is a scheme number one. Scheme number two is when we implement this runnable class, we are going to create a thread, and then you're going to call the thread by calling, we are going to call the start method of the thread. Okay, so in this case, all you have to do is just creating that runnable object. We don't have to call it ourselves because the thread will be created and started inside the constructor of this runnable object. Okay, all right. So the runnable thread test 1 and runnable test 2 program. So test 1 is using the scheme number 1 of runnable way. So runnable thread test 1 and test 2. So here, if you take a look at the code. So here we implemented the runnable interface, and this is a run method, and this is basically we created that runnable object, and then we passed that runnable object to the thread, and then we started ourselves, and we have another thread, and we have a third thread. Okay, so it actually results in pretty much the same as we have seen. And test 2 is the case that we have. So here in the constructor of this runnable class, we are creating a thread and then we are starting it inside a constructor. So in this case, all you have to do is just create that runnable object, and then inside the constructor, thread will be created and run. Okay, so it should actually result in the same result. Okay. Moving forward, so we just take a look at two ways of creating a thread. the first scheme, the first way of doing it is extending the thread class, and then the second way of doing it is implementing runnable interface. Okay, so let's compare these two schemes. So choosing the two is a matter of taste. You probably have seen examples of both. Okay. So implementing runnable interface may take more work since we still declare a thread object and can call the thread method on this object. And but again, big difference is that your class can still extend another class. So this scheme, extending the thread class, is easier to implement, and you cannot extend another class. So either scheme is actually fine. Okay, moving forward, thread group. So thread group is representing a set of threads, and a thread group can include other thread groups. So in a sense, thread groups will form a tree structure. Okay. A thread is allowed to access information about its own thread group, but not to access information about the parent thread group or any other thread group. So here we created 3 threads, and then we started that thread. Now these threads are being created from the main thread. So when you you can call this is thread, and then this is a static method of the thread, and then you can get the thread group name. So you can get the thread group object, and then basically we are just displaying the names of each thread. Okay. All right, so thread group test. So here we have we just display. We studied a 3 threads, and there are in fact 4 threads because we have a main thread, and then we have 3 threads that we created from the main thread, and so we have 4 threads in this thread group. Okay, so again, if you take a look at the code, so we created 3 threads. Okay, and so we have a thread group. So if you display the thread group, it is actually main method. It's actually main. Okay, and then we just display each thread in each thread in this main thread group. Okay, so again, pretty straightforward. Okay, another important topic is synchronization. The reason we need to have a synchronization is because of race conditions, so-called. So race conditions occur when multiple simultaneously executing threads access the same object, sometimes called shared resource. And if you're not doing things in synchronized fashion, unexpected result could generated. So example is, threads often share a common resource, for example, like a file. And if some threads are writing something and some threads are reading something, and it might actually the result of reading might be a little bit gobbled, the data. Okay. All right, so we need to have a synchronization of these threads. So this is an example of unsynchronized application. So we created the class implementing runnable. Okay, and here basically we are going to so here basically we have string 1 and string 2, and here we are creating a thread and we are starting it inside a constructor. And here we are basically calling print method of another class called the toStrings, okay, passing this string 1 and string 2. So here in this main method, we are basically creating new thread. So we are creating 3 threads, passing hello and there, and how are you, and two strings basically. What we want is that we want to display these two in sequence instead of gobbled messages. Okay, so when you're running this application, this is what you might get, like hello, how are you, and thank you, and things like that. So what I want is hello. We want this hello and there to be in sequence, and how are you in the in sequence. Okay. All right, so let's actually take a look at this. Yeah, actually, I should actually showed you the code of two strings. Okay. All right, so let me actually show that code. Synchronize example unsynchronized. So let's run this application, and you can see the results are kind of gobbled. Okay, so let's take a look at the code. So this is basically creating 3 print strings thread, and this is the print string thread implementing runnable, and there is no synchronization. Now two strings, the Java is basically doing this. It prints the first string, and then it sleep 500 milliseconds, and then it print the second string. What we want to do is, what's happening without synchronization is that once the first thread prints this first one, the second thread kicks in, will own the CPU, and then it will actually print its own string 1, and then at some point this string 2 of the first thread gets executed. So these threads are basically intercepting each other in this the sleep mode here. Okay, so what we want to do is we want to perform synchronization when this code is being executed, so that we have string 1 and string 2 get displayed in sequence. Okay, so that's the synchronization scheme that we want to implement. Okay, so some concepts in Java. So there is a concept of synchronization log in Java. So sometimes it's called the synchronization monitor. So Java offers synchronization monitor on every object instance, because every object instance, let me actually explain this one first. Java offers synchronization monitor on each instance of object class, so that it can be used as a log, synchronization log. Because this synchronization monitor is supported on object class, every object in Java, because it's a subclass of object class, can be used as a synchronization log object. Okay, so this is a concept of synchronization monitor or synchronization log. So you can think of a synchronization monitor and synchronization log the same thing, meaning any object in Java can be used as a synchronization log object. Okay, so a little bit more explanation of what we just talked about. Now, threads are synchronized through object monitor, meaning this synchronization log. Okay, I'm hearing some static noise. Are you hearing some static noise by any chance? Yeah, okay. I'm not sure why that's the case. In the meantime, let me just... Okay, so threads are synchronized through an object monitor, meaning synchronized log. Okay, now only the thread that owns the object monitor, meaning the log, can execute the block of code that needs to be synchronized. So that is that code, the block of code that needs to be synchronized. The terminology we are going to use is synchronized block. Okay, so there is only one thread who can execute the code in the synchronized block, and the code that can execute the synchronized block is the one that owns synchronized log. Okay, and when the synchronized block finishes, meaning the code is finished, then object monitor is then released, meaning the owner thread of the log will release the log. So any other thread waiting for that the synchronized lock, well, object monitor, will be then chosen to be the owner of the object monitor. So this is the way the multiple threads can be run in a synchronized fashion. So the key point is that only a single thread is able to run the synchronized block at a single time, and that thread is the one that owns the synchronized object. Okay. Okay. So if you don't understand what I meant by synchronized the object, that's fine. We are going to actually look at some examples and you'll have a better understanding. Okay. Now, a thread becomes the owner of the object monitor, synchronized lock, in one of the three ways. So using synchronized static method, meaning you're using synchronized with a static method. Option 2 is using synchronized instance, using synchronize on the instance method, and or the third scheme is using synchronized state on a common object. Okay, so let's take a look at each of these in a bit more detail. Okay, so this is an example where we are, we provide a synchronized with a static method. Okay, so this static method will be executed by a thread that owns the synchronized lock. So in this case, what is a synchronized lock? Synchronized object. So in this case, all the statement in the method becomes a synchronized block, and the class object is the lock object. Okay, so it's using the class object of these two strings, okay, as synchronized lock object. Okay. So the code is here. Again, this is the print string thread implementing runnable, and then we are basically calling print method of these two strings, the class. Okay. Okay, so this is the print string thread. Now the main class will create three of these print string thread. Okay. So in this case, when you run the application, then things are working as expected. We'll have hello there and how are you and thank you very much. It's because this block of code will be executed by owning the owner of the synchronized log object. In this case, synchronized log object is a class object. Okay. Okay, so option number 2 is now we are going to use synchronized with instance method. So in this case, the synchronized log object is instance object of this class. Okay, you see the difference? In the option 1, we were using synchronize against the static method. Here, right? In this case, synchronized log object is using is the class object. Okay. By the way, you can the class itself is an object, so it is actually class object representing this class. Okay. Now in option 2, here we are using synchronized against the instance method. In this case, synchronization log object is using is instance object of this two string class. Okay, so I'm going to actually show some examples of what it means in the when we look into the hands-on lab of it. Okay, so this is so let's take a look at the first case, and static 1. So this is the case. This is the case that we are using synchronized statement with the static method. Okay. All right. And we have this print string thread class extending runnable. Okay. And then we have synchronized example here, basically creating 3 threads. So when we run this application, it should run as expected. hello there, and how are you, and thank you very much. Okay, that's cool. Now let's take a look at the oh, okay, actually I want to actually perform example 2 as well. So let's run the example 2. So example 2, so we have a toStrings class. Now we are using synchronized against the instance method. Now synchronized log object that is being used to log is instance object of these toStrings. Okay, so when we are creating, print string thread, we have to actually provide a single instance object of this toString. Okay, so that common synchronized log object is used for synchronization. So if you take a look at the print strings thread.java, now it's actually receiving toString object that is created from the main method, and then that's the one that is actually being used for as a synchronized log object. Okay, now let's take a look at another example here. So here we are going to take a look at the this code. It's actually a little bit similar code of this example 2, in which we are using synchronize against the instance method. Okay, so here we are using synchronized with this instance method. So as I said before, when you're using synchronized with instance method, then object instance of this class will be used as a synchronized log. Okay, now in this case, what we do here is that we are not really passing commonly used toStrings object. So here we are creating brand new one. So each thread will create its own synchronized log object. Okay, so it create toString synchronized log object. So when you run this application, it's not synchronized. Anybody can tell me why this is the case? I kind of give you a hint a bit. Anybody? So even though we use the synchronized statement here in toString, here, somehow it is not synchronized. The threads are not synchronizing themselves. Yes, so Paul came back with a message that it's not using the object instance. Well, I'll give you 50 points out of 100. It's not using the same object instance. It's using individually created object instance. You see what I'm saying? So if you take a look at in this case, toStrings, this is toString. Yeah, here. So this is the code. So in this case, the toStrings object is created per each thread. So each thread is synchronizing the code using different toStrings object. Okay, so that's the reason it's not really synchronizing themselves, because even though it's using synchronized method, it's actually synchronizing just by itself. Is that clear? So just for the exercise, what we can do is, I have another code here, this guy. Oh, here. So, I just create these toStrings. Instead of the instance variable, I actually made it a static. So that all the threads, all the object instance of this thread will actually share the same static object instance. Static object instance of toString. In that case, it's actually using this toString object instance. This is a common, the synchronized log object that are being used by all these threads. So in this case, if you're running this application, then it is behaving as expected. Okay, because it's using common synchronized log object. Okay, so hopefully that gives you a sense of what is the concept of synchronized log object. All right, moving forward. Now, option 3 is, in this case, we are going to actually create, our own object, and then we're going to use as a, synchronized log object. So here, basically what we do is, yes, so this is the code. So inside the run, we are going to use this common. In this case, this is going to be common because we actually pass that common the toString object, okay? And then we are specifically specifying a particular object instance, and we are using it as a synchronized log. Okay, I mean this object could be any object. Okay, so this one also should actually behave the same. So again, let's take a look at the example 3. So this one should behave as expected, it's synchronized. And here so here we're actually passing the toStrings object, and we are going to use toStrings object as a synchronized object that we are going to in the code. So here we are specifying synchronized with a particular object instance that we designated as a synchronized log. Okay, and because this is the same object, because we are actually passing that guy, whenever whenever a thread is created, we also pass the common toStrings object. Okay, all right. Okay, so now moving forward, now inter-thread communication. So why we need to have threads to be able to communicate among themselves. Okay, so typical example that we use to explain this need is producer and consumer example. So if you think about the scenario in which there are two threads, both operating a single shared data area that needs to be synchronized. So one thread is called the producer, and its job is to insert data into the data area, while the consumer thread removes the data from the same area. Okay. Now, in order for the producer to insert data into the data area, there must be enough space. Okay. And for consumer to be able to remove data from the data area, there must be data there in the first place. Okay, so the role of consumer is just remove the data from a data area. Okay. Now, let me just move on with the case where things are not synchronized. So there is no communication between this producer and consumer thread, and we'll actually see the consequence, and then we'll explain why the communication between these two threads would be needed. So we have a very simple class called the cubbyhole. And this is the data area called contents. It's just the int variable. And then we have a getter method. A get method will just return this int variable. And then we have put method that is used by the producer to place the number into this contents. And this get is used by the consumer thread to get the number. Okay. So again, this is not the case where things are synchronized. I'm sorry, this is not the case where we have communication between these two threads. So here we have a producer class. This is a producer thread. Okay. So basically, the producer thread is just putting numbers, putting number from 0 to 9. Okay. And then we have a consumer thread, which is basically just getting the number. Okay. Now, when you run this application, so this is the main code. We create the cubbyhole, the object, and then we are running producer thread and consumer thread. We create these two the classes, and then we are running this producer and consumer thread. Now, there is no inter-thread communication scheme implemented here. So what happens is, the result. Let me actually show the result first. The result is like this. The consumer actually run first, and it just got nothing. And then producer put all these numbers. So there is no communication. Consumer doesn't get anything because consumer actually run fast before the producer, thread gets started. Okay. Now, the problem is, in this case, if a consumer wants to retrieve a data, in this case, a number from the synchronized area, the consumer just keep polling. It has to call get, and if there is something, then it will get the number. If there is nothing, then it will actually have, the null value or something like that. So the consumer has to do polling, in fact, wasting CPU cycles, while it is waiting for the producer to put the number, meaning produce. Okay. The same thing with the producer. Producer, because there is only one, the integer, producer do not want to override it, right? So producer has to wait until the consumer take it out. Okay. So the producer again, has to poll whether that space is available or not. Okay, so that is actually the first problem. The CPU resources being wasted because both consumer and producer threads are polling to this job. And results are, of course, unpredictable. Okay, so in the case that a number may be read before a number has been produced. Okay, so that's the case of this. Right, and multiple numbers, the producer might actually, so in this case, this one probably doesn't apply because we have only one, integer. Okay, so let's run the unsynchronized case. Oh, okay, so I was actually looking for this producer and consumer unsynchronized. Yeah, so this is a result you get. So consumer thread got started first and it finished them all, and then producer thread get executed. So there is no communication between the two. So what we want is, we want the consumer to wait until producer put the number into the synchronized area. Okay. And we want the producer to wait until there's a space to put the number. So that's the communication scheme that we want to implement. So for this inter-thread communication, the Java provides a set of methods, again from object class. So again, any object instance can have this wait and notify all. So basically, wait causes the thread wait until some another thread calls the notify or notifies. Basically, whenever you are waiting for something, some another thread to do its work, you are going to call wait. Okay, and then that thread will be woken up when somebody called notify. Okay, so we're going to take a look at these things in a bit more detail. So wait method is defined in object class. So every Java class inherits wait method, meaning every object instance can be invoked with the wait method. So what happens is when the wait method is invoked, it basically causes a thread to release the synchronized log is holding on that, on an object, so that other thread to be able to run. Okay. So wait, by the way, because we are dealing with a synchronized code, wait can be only invoked within synchronized code. Okay. And wait can only be invoked by the thread that owns the lock on the object. Okay. And also you have to actually have it in a try block. Okay, so when wait is called, the thread becomes dormant until one of the four things occur. So another thread calls notify method for the object, or another thread invokes the notify all method for this object, and another thread interrupts this thread, and the specified wait time elapses. So we are going to look into these two cases, notify and notify all. Okay. So when one of these occurs, the thread becomes re-available for thread scheduler and competes for lock the object. Okay, and once it regains the lock of the object, then it resumes where it becomes dormant. So notify method is basically wakes up a single thread, while notify all wakes up all threads. So wakes up single thread that is waiting on this object monitor. So object monitor is basically we're talking about the synchronized log object. If any threads are waiting on this object, one of them will be chosen to be awakened. And this choice is again arbitrary, and again it occurs. The choice is going to be done implementation dependent. Again, it can be used only within the synchronized code. And then awakened thread will not be available to proceed until the current thread relinquish the lock on this object. Okay. All right, so let's, this is notify all. So same thing with the notify, but this is actually waiting all threads. And in this case, highest priority thread will run first. Okay, so this is the code. So now we are providing some communication between producer thread and consumer thread. Okay, so we have synchronized on get. Okay, now when the data is not available, that's the case when available flag is false. Then we want to wait. Okay, because there is nothing to get. Okay, so at this point, it relinquished the lock. So somebody else will be able to execute the code. And when control is back, so this is the case when notify or notify all methods are invoked by another thread. So control is back here, okay, and that means this guy actually has a lock again. Okay, so it's basically to return the contents, and it refreshes the flag to false. Okay, and notify all is basically wake up all threads waiting for the lock to be released. This is a case for the put, and we are doing the same thing. It calls wait, and then eventually, when you're actually putting things, so when available is true, that means the producer do not want to put the new number into it because it's not taken. So when it's true, when available is true, it wants to wait. And when it is taken, that means available is now false. Then control is back here, and then is setting the value, and then it will actually make available true, and then call notify all. So the thread in this case is waking up the consumer thread here, and here these notify all will wake up the producer thread. So when we run this application, then we are basically running as expected. So producer put the number, and then consumer get the number, and then producer put the number, and the consumer put the number. Things like that. Okay, so this is what we actually wanted. So let's see. So in this case, synchronized run, and this is what is expected. Okay, so that is the code that we just look into from the presentation. This one. Okay. All right. So since we talked about this one in the presentation, yeah, I put the detailed explanation of the logic. So hopefully you will actually have a better understanding. Okay. So let's see. The last topic is scheduling a task via timer and timer task classes. This is relatively straightforward concept, so I'm going to just look into the code. So we are basically scheduling new remind task in terms of 1,000 seconds. Okay, and this is a task that will be performed. Okay. All right. So let me actually spend the next 5 minutes going over some of the hands-on lab exercises. Since we have actually take a look at the some of this code in the hands-on lab during the presentation, I'm going to actually move a bit faster on this. Yeah, so exercise 1 is extending thread class. So two different schemes for extending class here. So start method is not in the constructor, and start method is in the constructor. Okay, so that's something that we have seen. So moving forward, so this is a case that we have a start method inside the constructor method of the subclass of the thread class. Okay, and exercise 2 is implementing runnable interface. Okay, so again, there are two different schemes. Start method is in the constructor, and start method is not in the constructor. Okay, so again, we have seen this code. And exercise 3 is thread group and viewer thread and thread priority. So again, it's relatively simple things. So I'm gonna just move ahead. Yeah, you can set the priority if you want to. Yeah, so this is actually interesting code. So here we created a simple thread, and then we started it, and then we set the first thread priority 10. Then we create the second thread from the same code, and then we set the second thread priority to 5, and then we started it. We started and set the priority, and same thing with the third thread, and then this one we set the priority 1. This is the lowest priority. So when you run the application, you can see the first, the few iteration is actually running the thread 1 and 2 and 3, and then eventually it will actually run only the thread that is a priority 10. Okay, and then it will run the priority 5, and then it will run priority 1. Okay, so whenever context switch occurs, it will take a look at which one has the highest priority, and then it will be running that priority task first. Okay, exercise 4 is the synchronization. Again, that's something that we take a look at in the code. So, we have again the play around with the 3 different schemes. Okay, so here we have, so the first one is not synchronized case. We are not synchronizing at all. Okay, so we have a gobbled result. And now we are synchronizing on the static method. So here we are synchronizing on static method. Okay, so in this case, what is the object instance that is being used as a synchronized log? Anybody? Yeah, I'm asking you guys. So in this case, static object, I'm sorry, not static object, the class object of these 2 strings class is used as a synchronized log object. Okay. This is a case that we are using synchronized instance method. So in this case, we are using instance object of these 2 strings class as a synchronized log object. Okay, because we are actually using common synchronized instance object, this should work. Okay, now this 4.4 is experimentation that that doesn't really working. That does not work because we were not using common synchronized instance object. So here, as I explained before, each thread is using its own synchronized log object. Okay, so these 3 threads are not synchronizing against each other because each one is using its own synchronized instance object. Okay, so that's something that so you can see the results are gobbled. And the last one is using, you designate a common sum object. Okay, so here we are using 2 strings object ourselves, but you can use any object. Okay, and exercise 5 is inter-thread communication. This is again producer and consumer example. So this is a case that we are not providing any communication between these two threads. So the results are like this. And so 5.2, now we are synchronizing these 2 threads, producer and consumer thread, using wait and notify all or notify. Okay. So again, when you run the application, it's working as expected. And exercise 6 is for timer and timer task. Okay, so you can run a task one-time execution, or you can perform repeatable the task. So this is the case, repeating task. Okay, so you can actually have so you can schedule remind task, initial delay, and subsequent rate. Okay, so that's the end of the presentation. So let me just finish.